All right, let's talk our way through this thing. What's the first thing I want to do as I approach this problem? Factor. Okay, so I've got this guy down here. We need to factor this. No GCF. Awesome.
Can use your shortcut.
Can use the shortcut because x squared is 1. A times c, 1 times negative 10. So I need two numbers that multiply to negative 10, but that add to negative 3.
Back to 5 and 2.
Negative 5, positive 2. Did anybody notice, this isn't always 100%, but did anybody notice on those first two fractions, those denominators? Yeah, we had x minus 5, x plus 2. It's not always 100% true that that's going to be what that last denominator is going to factor to. But it's a pretty good guide to help you start thinking of things that it might be. So yeah, that was not an accident. And when you see it happen repeatedly, that's definitely not an accident. Good job on the pattern recognition there. So I'm going to bring this down, set it equal to 14 over, and then I'm going to write this in its factored form, x minus 5, x plus 2. All right, we've got that denominator factored. What was the purpose of factoring the denominator?
LCD.
So that we can find our LCD. Because remember, for our LCD, we want to grab things the fewest number of times possible to make all of our denominators cancel. If you grab too many things, it's going to make a lot of work and it's going to make it very complicated. What should my LCD be?
X plus 2 and x minus 5.
Yep, x plus 2 and x minus 5. So that's what we're going to multiply each term by. And what happens in my first term?
X plus 2 cancels out.
X plus 2 cancels out, and so I still have x and x minus 5. Bring down my plus sign. Who cancels here?
X minus 5.
X minus 5 cancels, so I have 7 times x plus 2. Drop my equal sign, and what about over here? All of them except nice job, all of them except the 14. Okay, before we go any further, why was it that I was allowed to totally get rid of the denominators? I didn't have to find a common denominator. What symbol at the beginning made it possible to get rid of the fractions? The equivalent sign, the equal sign. If it doesn't have an equal sign, then I don't have another side to do the same thing to. So remember, the rules are if you do it to one side, you have to do it to the other side. If I don't have an equal sign, I can't get rid of the denominators. And I have to find a common denominator. We practiced that on the bell work like 2 days ago. All right, where to from here? Distribute. Thank you, ma'am. So I'm going to distribute. What is x times x? X squared. X times negative 5. Minus 5x. Then I'm going to distribute a positive 7 or a negative 7? Positive 7 times x plus 7x. And positive 7 getting distributed to a positive 2 plus 14 equals 14. How can I approach this now? Like terms. What are the like terms we're going to combine? Negative 5x plus 7x. What's negative 5 plus 7? 2. Positive 2. Nice catch there. X squared plus 2x plus 14 equals 14. Set it equal to 0 by doing what? Minus 14 on both sides. So it cancels here and it cancels here because 14 minus 14 is 0. So I've got x squared plus 2x equals 0. Why did we set it equal to 0? Because it's quadratic. Anytime we see a quadratic, we need to make sure that it's set equal to 0 if it's an equation. Okay, I've got it equal to 0. What do we do now? Starts with an F.
Factor.
Factor.
Thankfully, A is still 1, so.
A is still 1. What do we always look for first when we factor? GCF. Be careful before you answer. X. Nice work. GCF is X. So I'm going to bring the X out to the front. Tell me what I have remaining. X plus 2. Do we still have anything that's squared?
No.
So do I need to keep factoring? How many factors do I have?
2.
2. What are they?
X and X plus 2.
X and X plus 2. We're going to take each factor and set it equal to 0. This one is done. It's got X isolated. What do I need to do to the other one to get X isolated? Minus 2 on both sides. So I get X equals -2. Am I done?
Funny enough, you gotta find out valid and extraneous. Funny enough, 0 is the valid one and -2 is the extraneous one.
How's that possible? I thought we said 0 couldn't work.
0 plus 2 is 2. 0 minus 5 is -5.
Nice job. Remember, it's the denominators that can't be 0, not X. So we're going to check that the denominator does not equal 0. So our denominators are X plus 2. That doesn't equal 0. X minus 5. That does not equal 0. Since the other denominator factored to just be those two, I don't have to put it into the third one. You can, we can double check. If I put 0 in the place of X here, I'd have 0 squared minus 3 times 0 minus 10. What's 0 squared?
0.
0. 3 times 0?
0.
0. And then minus 10. -10. That's not 0, so I'm happy with it. That means that this one is indeed valid.
But unlike -2 equaling X, it gets extraneous in the first part.
In the first denominator, if I put -2 in the place of X plus 2, that equals 0. That means we have to throw this one out as extraneous. Nice work on that one, guys. I tried to trick you with the 0 there, but you were not fooled. Very good work. Okay. Rest of class today, I'm going to give you guys independent work time. I'm going to pass out the review for the test and the cheat sheet that you get to use. So you guys can begin working on that today. I will be, while you're working on the review, I'm going to post the answers. Not my work, just the answers. I'll post the work later, but for today, I want you to be able to check your answers as you work through this so that you know whether or not you're on the right track, you know whether or not you need to ask for help. Okay? So I'll pass that out, and you guys have the remainder of the time to do that.